We just added a new transaction verification method to the transaction class. Let's add some tests to ensure that the signature verification works properly by validating a valid transaction and invalidating a corrupt one with the same function. These two tests, in and of itself, will also prove that signatures themselves are properly generated for transaction objects. First off, let's add a method within the transaction test class that checks whether the class validates a valid transaction. So after the input test, let's have a new test that says it validates a valid transaction. Then we have our familiar arrow callback function. Because of the before each block, every unit test will have a fresh transaction object. Right here in transaction equals new transaction. Since this transaction hasn't been corrupted, well, we know that it's valid. So we'll expect that if we use this within the verify transaction method, it should be true. So let's add an expectation. We're going to expect that if we use the transaction.verify transaction method, and then we pass in this transaction object that hasn't been corrupted yet, well, we'll expect that to be true. Great. Likewise, let's add a test that invalidates a corrupt transaction. So we're going to say it invalidates a corrupt transaction. And then we have our callback arrow function. In this test, we'll immediately corrupt the transaction by taking the first output and changing its amount to something obscene. So let's go into the transaction. We'll look at its outputs, and then we'll access the first one at index 0, and then we'll change its amount to something really large like 50,000. There's no way someone has that much currency yet. Now we'll expect that if we ask the transaction class to verify the transaction, just like above, well, this time it should be false. So again, we're going to use the transaction.verify transaction method, and then as the input, we'll have the transaction object that we just corrupted, and then we'll expect that to be false. Just like so. All right, so overall, we should have two new unit tests. One, it validates a valid transaction and expects it to be true. In the second test, you should have one to invalidate a corrupt transaction, actually corrupt the transaction by changing the output amount, and then you'll expect that to be false in the verify transaction method. So with that, we're ready to go to the command line and then run our testing script and then check if these tests actually pass. So go ahead and open up the command line, and then the command is npm run test, just as before. As we do so, what we find is that indeed we have a fully passing test suite if all goes well. Great. This shows transactions do indeed come with signatures, and furthermore, that transactions verify valid ones but invalidate corrupt ones. Therefore, we can trust that transactions do indeed come from their original senders because of the unique signatures that are attached to them.